In this video, I am going to go over the 5.0 Chem online final exam practice quiz, and this one is going to cover stoichiometry. So in this first problem, we have to make sure you can write formulas right. What is the formula for calcium chloride? Now, calcium has a +2 oxidation number, and when it says chloride, it ending in IDE here, that's giving you an indication that you're just looking at chlorine off the periodic table. If you look at the polyatomic ion list, you're not going to see chloride. You'll see chlorite and chlorate and things like that, but not chloride. Most anions that end in IDE are off the periodic table. There are a couple exceptions, the most common one being hydroxide, but usually IDE just means the anion is off the periodic table. So when we put these together, you crisscross the oxidation numbers, you get CaCl2, which is that one right there. Sodium carbonate, now we're going to do the same general thing. Sodium has a +1 oxidation number, carbonate CO3 with a -2. You crisscross the numbers, you get Na2CO3, which is that one right there. And now this is asking, if we have those things reacting with each other, what are the products going to be? So at this point, it's easier to write out the charges again. You have calcium chloride, that's a Ca with a +2, a chloride is Cl with a -1. You're going to have sodium carbonate, that's Na+1, carbonate CO3 -2, and that's where we got the two reactants from. So now for the products, really what's going to happen is this is going to be a double displacement. Everything's just switching partners. The calcium is going to bond to the carbonate. It's a +2 with a -2, so you get CaCO3. And now you're going to have the sodium, that's +1, bonding to the chloride, that's -1. You get NaCl. So what you're getting is the positive from one bonding to the negative to the other. So you get sodium chloride and calcium carbonate. All right, that's what it's asking you. Now on the next page, we're working with the same equation at first, and it's saying when calcium chloride is reacted with sodium carbonate, all of the substances have a coefficient of 1 except for one of the products. Which product will have a coefficient greater than 1, and what would the coefficient be? So it's really asking you to balance it. So I just rewrote the equation here just to make it a little easier. We want to make sure you have the same number of each element on each side. So there's a 1 calcium, 2 chlorines on the left, so I'm going to put a 2 here to give me 2 chlorines. That gives me 2 sodium. There's 2 sodium. We can balance this whole carbonate together. There's 1 carbonate here and 1 carbonate here. So it's balanced like that, just a 2 in front of the NaCl. So when we pick our answer here, it's sodium chloride, and the coefficient that went with it was that 2. All right, now I'm going to keep this reaction written out on a piece of paper because we'll need it again. Now this is saying calcium chloride reacts with sodium carbonate. 5.00 grams of calcium chloride reacts. How much sodium chloride will form? Assume there's excess sodium carbonate. So what it's saying is we're starting off with 5 grams of that calcium chloride. We have excess sodium carbonate. So the 5 grams is going to be, the 5 grams of calcium chloride is going to be the amount that dictates how much of each product we're going to get. And they specifically want to know how much sodium chloride. So we're going to figure out grams of sodium chloride. So I'll bring this back. We'll need this again. So start off with what you're given, 5.00 grams of calcium chloride. First thing you have to do is convert this grams into moles. So you're going to put grams of calcium chloride on the bottom. You're going to put 1 mole of calcium chloride up top. Now we have to figure out the molar mass of this. Calcium's 40.1, chlorine is 35.5 a piece. There's 2 of them, so that's 71.0. Add all that up and you get 111 grams of calcium chloride. So now grams of calcium chloride will cancel out. Right now what you're left with is moles of calcium chloride, so that has to go on the bottom. Now I can't go from moles of calcium chloride directly to grams of sodium chloride. There's no conversion factor to let you do that all in one step. So what I have to do is convert it to moles of sodium chloride, and this is where I need the reaction again. It's 1 mole of calcium chloride, so that's what's going to go here, to 2 moles of sodium chloride, and that's where the 2 comes in, right? So these numbers in this mole ratio are from the coefficients in the balanced equation. The moles of calcium chloride cancel out, and right now what we have left is moles of sodium chloride, and I can easily turn that into grams using the molar mass. Sodium is 23.0 off the periodic table, chlorine is 35.5, so when you add all that up you get 58.5 grams. Now if you do this math, it's 5 divided by 111.1 multiplied by 2 multiplied by 58.5. If you do all that math and you round it off to 3 significant digits, because that's what's in the problem, you get 5.27 grams of NaCl. Okay. Now the last problem is a little different because it brings liters into the mix. How many liters of carbon dioxide are formed when 23.0 grams of C12H8 is burned in excess oxygen gas? Alright, so we have to write out the equation first. What it's telling us is that you have C12H8 reacting with oxygen. And when you see that, you should realize that that is a combustion reaction. Now it's telling you carbon dioxide is formed. Right, and that's what's always going to happen in combustion. You're always going to have a hydrocarbon mixing with oxygen. You get carbon dioxide, and the other product you get is H2O. Now we have to balance this. You have 12 carbons on the left, so I'm going to put a 12 here in front of CO2 to give me 12 carbons. You have 8 hydrogens on the left, so I need a 4 in front of water to give me 8 hydrogens. Now oxygens, there's 24, plus another 4 is 28, so I have to put a 14 in front of O2. So now it's balanced, and you always have to balance the equations because remember you need those coefficients in the mole ratio step, so you have to make sure you balance it. It's not always going to be 1 to 1. Now this is telling us that we are burning 23.0 grams of C12H8, and it wants to know how many liters of carbon dioxide are we going to get. So start off with what you're given in the problem, 23.0 grams of C12H8, and we can convert that to moles. So you put grams on the bottom, 1 mole up top of C12H8, and carbon is 12.0 a piece, and there's 12 of them, so that's 144, plus the 8 from the hydrogen, that's giving you 152.0 grams of C12H8. Grams of C12H8 cancel out. What you're left with is moles of C12H8, so that can go on the bottom. Now again, I can't go from moles of one thing to liters of another compound, CO2 in this case. So what I have to do is convert it to moles of CO2, and this is the mole ratio. It's 1 mole of C12H8 to 12 moles of CO2. So now moles of C12H8 cancel out. And now what's slightly different in this step, well, we still put moles on the bottom and it's still 1 mole, right, because we need the moles of CO2 to cancel out. But this problem was asking me for liters. Now we have to assume that this is done at STP because it's not telling us anything different. And at standard temperature and pressure, if you have 1 mole of any gas, it doesn't matter which gas it is, it's 22.4 liters is the volume. Right, so that's the part you have to remember. Now, if it wasn't at STP, that wouldn't be the case, but usually for stoichiometry, we would have it at STP, so you could use this number. So now when you're doing this problem, you do 23 divided by 152 times 12 times 22.4, and if you do all that right and you round it off to the right number of significant digits, you should get 40.7 liters of CO2. That's the video for stoichiometry.